welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always on a wet, cold and very rainy November in 2022. I thought I'd make a quick video because I often get this kind of what I would call generic hi-fi valve amp in for repair. They are there are dozens and dozens and dozens of different brands. You know, you can get Chinese ones, Japanese ones and everything. And if usually a couple of stages of preamp and a Class A power valve, and people use them for their hi-fi. And I do get them in, I'd say 10 or 20 a year come in. And so I thought I'd show you, not because this particular model will be of any interest to you, but just a general fault finding process with these kind of amps. Now you can get a bit lucky with these. Quite often the fault is one channel's lower volume than the other. I would say like 5 times out of 6 that's the fault. So I'll talk you through how I deal with that. And the very first thing that I would do, of course, would be to swap the valves from one side of the amp to the other, because we've only got 3 valves in either side. And 9 times out of 10 it turns out to be the valves. I order a set of valves and put them in. It's not terribly interesting, but I thought you'd like to see that. Might be something more wrong with this amp, but the first thing we'll do is to get it up on the scope, get a signal into it and verify that one channel is low and find out which channel it is. Then we can do our valve swap routine and see if that gets us out of trouble. So just a quick look at this amp. It's nothing special, 10 a penny these in terms of their commonness. I don't mean their cheapness. Sometimes they're quite expensive, these valves. People will pay a lot for a valve power amp. Anyway, this is a Fatman TLA, never heard of it. And as you can probably just about see inside, we have a central valve there. That might be a rectifier valve, I'm not quite sure. And then we've got 2 preamp valves, look, and a power valve of some sort, KT88 maybe, and the same the other side. So it's just a stereo amp. The central valve will be okay. I expect that's the rectifier. So let's get it hooked up and get a signal going through it. And what I always do with an amp is to verify that what the customer's told me is actually the case. Okay, here's the setup. I've got just one channel coming out, the right channel, and that goes to my dummy load, onto which I hook a scope, and I've set my signal generator down there so that I've got about 2.5 volts peak to peak. Nothing special about 2.5 volts. That's just what we've got. So on the right channel we have 2.5 volts peak to peak. So I'm now just going to swap the connections over to the left channel and see what we've got there. I forget which channel he said now was a bit low. So let's just quickly swap those connections and see what we've got. Okay, same input signal, and we're now on the left channel, and look, we've only got just over 2 volts. 1 volt, I beg your pardon. It's on 500 millivolts per division, so just over 1 volt. We had 2.5 before, so there's a big difference in the gain here. The left hand channel is down by 50%. Right, so I'll make a note of that, and then we will do the next stage, and I'll show you how to do that. I just thought I'd show you the incredibly naff way they've decided to hold this grill on top of here. You'd expect them to have a couple of screws down here or something, but no, the screws are right down inside there, right down in the bottom there. You can just about see it there, can't you? And to get it you have to access it through this top here with a long screwdriver, and that's okay, but when you come to put the screw back on, it's exceptionally difficult to do that, or even to take the screw out, because you're going to have to find a way of gluing it to the end of this screwdriver or something, and trying to do it. You can't get a finger in there to do it. That's absolutely rubbish, that. I'll be able to do it. I just thought I'd mention though how poor that is, because don't forget this is a user serviceable part. It's not like you expect a technician to do this. You would expect the user to change the valves from time to time, and so they have to have exactly the right length screwdriver, quite a long one, small Phillips head, and then find some way of getting that screw back in. I've got some tips and tricks obviously, but it's not good, is it? Anyway, let's get this grill off and have a look at the valves. Okay, that's the grill off. Actually, it wasn't quite as bad as I thought, because those screws, I don't know if you can see, are just kind of you know, resting there and there, so I'll be able to put this gingerly back on and do the screws up. So I take it all back to a certain extent. Right, now the next thing I always do is to confirm which is the left channel. Not actually very obvious which is the left channel. You might think that's the left channel because it's on the left, but it might not be. Might be left as viewed from the back. So we're now on the faulty channel. There it is there with the scope on. So I'm just literally going to pull a valve and see if it goes. Yeah, that's gone. So this is the left channel. So I'm going to mark this up now as the faulty channel. I'll leave that valve out. I'm just going to turn it off now to let the valves cool down, because I'm going to swap all the valves over in a moment. Now what I normally do, what I always do in fact, is to use one of these dots here. Very handy, these. I use these to mark faulty components. So I'm just literally going to mark up the faulty channel. It's very easy just to lose track of what you're doing. So we know that that channel is low and that channel is high, and we are now going to just swap the valves from that channel to that channel and see if this becomes high and that goes low. If it does, it's a relatively straightforward fix. If it doesn't, we're in for a bit of fun and games. Interesting valves here, 6N3, not valves I'm used to. This is a 6E2, never heard of it. Guessing it's a rectifier. And these are KT88s, which I have heard of, but these are quite stubby. I seem to remember KT88s being a little bit longer than that, so these might be kind of special stubby versions. Anyway, so I'm now just going to swap all the valves from one side to the other, and then we'll power up again. Just before I swapped the valves, I thought you'd like to know that I looked at that and thought, that looks a bit funny. And I looked it up, and this is a magic eye valve. I'm sure you know that, the sort of green light that comes up, and you know, it's a level control. How cute is that? I like magic eyes. It takes me right back to my younger days when I had a Grundig tape recorder with a magic eye level control. Absolutely wonderful. So we don't need to worry about that. That's just a level indicator. Right, let's push on and swap the valves over. Okay, I swapped the preamp valves over. These were too hot to touch, so I thought, oh, let's just check if it's the preamp valves first of all. So it isn't the preamp valves. We're now on the good channel there, and the right channel, and that's still good. And I've checked the left channel, and that's still bad, about half the volume. Let's just quickly check that now. I'm just going to connect these across to here, this across to here. And change the input to the left, and as you can see, we're down to a lot lower volume. So it's not the preamp valves. I wonder if it's the KT88s. I hope we don't have a complicated fault on this, because the trouble with these sort of amplifiers is it's not easy to get schematics for them. It won't be overly complicated inside, so I should be able to fix it even without a schematic, but it is much easier if you have a schematic. Anyway, we have another test we can do yet, which is swap the power valves over. So I'll just let those cool, swap them over and see what's going on. Okay, interesting. I swapped the power valves, and this is the good channel now. And oh, I'm on the bad channel. Oh no, fooled myself. We swapped the bad channel, didn't we? Okay, so the power valve swapped. This is the bad channel. Left, yeah. Oh yeah, okay, well, let's just double check that we still have exactly the same issue. And into there. Interesting. Got nothing at all now. Yeah, it's interesting, I was chasing my tail for a bit there on the good channel. I didn't have any output at all. Oh yes, this is very sensitive, this something here. Slightest movement on that valve, look, causing the signal to almost disappear. And that's on the good channel. Okay, might have to have a look at that, might need the valve basis cleaning. Anyway, off that red herring, where the hell are we? We are on the good channel, we're on the right channel, and we have 2.5 volts, and I'll just check the left again, and I'm pretty sure now that we still have a problem on the left, which is a shame because that means it's not valves, and we're going to have to get technical with the amp. Pity. Swap the channels here. There we go. Right, and we have a lower signal there. So we're still in the same situation. There's a problem with the amp which is not valve related. Okay, here we are on the underside of the amp, and as expected it's not complicated, you know, not much really to go wrong here. I thought what I'd do straight away, here are the input phonos, look, and they come via this bundle of leads into the input selector switch here. I think it goes off the volume control, bit of a weird volume control. Not sure what that is, if I'm absolutely honest. And then I happen to notice this, look, we've got ground, and it very clearly marked L in, left in, and R in, right in there. So the very first thing we're going to do is to put a signal in here and make sure we've got the same signal coming in on the actual input to the board. No point in trying to diagnose a faulty board if the actual signal level coming in here is incorrect. So let's do that. Okay, signal connected to the left input. I'm going to put the scope probe on the left input, and we have turned the gain down, got about 200 millivolts peak to peak. So let's do that for the right input and see if we have the same signal. Signal now going into the right input, there it is there, and over on the scope we have exactly the same signal. So that's nothing to do with this stereo pot or selector switch or any of that. So we have the same signal going into each amp side, but obviously there's a problem somewhere in the circuitry. Okay, making some progress. Okay, just picking this up, I've done a couple of things which I haven't shown you. The first thing I did was to check the DC conditions on the valves one side to the other. So basically just going around the pins of these two valves here, check the DC and see if it's similar to the DC conditions around the two valves here, and similarly on the power tube, and the answer to that is they are pretty similar, so there's no major problem there. Then I started thinking, you know, there's only a 50% reduction in signal, so it's not something major, you know, it's not some open circuit resistor or broken track or something. So then I don't know why I just suddenly had a thought that both of these valves here are cathode biased. I'll tell you about that in a moment, but this is the cathode bias resistor for each valve, and the AC is decoupled via a cathode bias resistor bypass capacitor, which is this one here. So there shouldn't, this goes to the cathode of each tube. There's the cathode, and that goes to the cathode. I'll tell you about it in a minute. I'll draw a little diagram for you, but there shouldn't be any signal on the cathode here, any AC signal, because it's decoupled by this capacitor. So I suddenly thought if one of these capacitors had gone down, there would be a signal on here, and any signal across this resistor gets lost from the main signal, so that would account for a reduction in signal. So I'll do that for you now. I'll hang a scope on here, we'll put a signal in and see if we get a signal, and I'll hang a scope on here and we'll put a signal in and see if we get a signal, and you can see what I discovered. Okay, we've got the signal going into the right channel. We're hanging on the right channel cathode, and there is no signal worth speaking about. You'd expect a little small signal like that, which is exactly what we're getting, 50 millivolts or so. Now let's do the same with the left channel and see. Let's put this up to 0.5 volt sensitivity, and let's see what we get on the left channel. So now the signal's going to the left channel. We're hanging on to the left channel cathode, and whoa, we've got volts of signal there. So this is the problem. Basically, the cathode bypass capacitor, which is this one here, has gone open circuit. Now let's prove that by hanging across this resistor a 100 microfarad 100 volt capacitor and see if that kills that cathode signal. Okay, so I've got my capacitor hanging off this crop clip here, and I'm just going to dab that crop clip onto the cathode, and when I do that we will have a look and see what happens to the signal. So here we go, 3, 2, 1, dab, and it kills it pretty much. Look, might be what you'd expect. Still some there, but I think that's our problem. So we're going to replace both of these capacitors. If one's gone, the other's probably gone. And when I've done that, we can check the output again and make sure they're both now the same. Okay, the good news is that did the trick, and we have an equal signal now on both channels. Now we've just got another problem on this amp here, in that this volume control is absolutely terrible. Normally no problem at all, of course. We just put a little squirt of deoxide or something down in it. However, this volume control, I'll just turn that down, this volume control is you know, pretty unusual. It's a completely sealed unit with this PCB on top. So I think I'm just going to have a go at taking the knob off, and just sometimes you can get lucky and a bit of deoxide or whatever will run down the shaft to be enough to clean the pot. If that doesn't work, we're going to have to take this out and have a look at it. I wonder how easy that is. Yeah, I tell you what, let's just let's take the knob off and see how easy it is to get this pot out. It might be worth just doing that. The knob came off fairly easily with a bit of leverage. Let's see if we can get the actual pot out. Might just be a little hole in it or something that we can put some cleaner through. A squirt of deoxide will sort this out immediately if we can get anything in there. Right, I'm just going to put the camera down a minute and just get that out of there. And of course these idiots have made it so that you have to remove the entire printer circuit board, take the entire amplifier apart in order to get this module out of here, because it fouls against the printer circuit board there. There's actually no way that'll come out. Unbelievable, isn't it, really? Stupidity. Okay, well, I've got nothing for it but to see if we can get some deoxide down the pot shaft. See if we get lucky there. Right, well, we got incredibly lucky there. I squirted deoxide down the shaft, worked it backwards and forwards for about 20 minutes, and it's a little bit noisy just down there, but that horrible crackling is gone. And I think I'm going to ask the customer to see if you can live with that rather than completely dismantle the amp. I promised to talk you through the situation in this amplifier, so let me just remind you about the two sorts of bias. in any valve that we need to bias, we have to hold the grid, that's that bit there, negative with respect to the cathode, that's that bit there. And the anode normally goes up to HT via some load. I won't go into why that is, I've done other videos on it, but anyway, just all you need to know is to bias any valve, the grid needs to be negative with respect to the cathode. I mean, the cathode could be at 1,000,000 volts, as long as this is at 950, you know, that's negative with respect to the cathode. So there are two ways of doing that. One's called fixed bias, where we pretty much hold the cathode down to ground, and then we put some negative DC voltage on here. In a power amp you'd have a bias pot which you adjusted to set the negative voltage on here, minus 35 volts, minus 40 volts, that sort of thing. And that adjusts the tick over rate on the valve. And then of course don't forget this is DC, we superimpose on that our AC, which causes the current to go up and down through the load and amplify as we want. So that's a standard bias setup on class AB amps. Of course you've got two of these in push-pull, but we won't go into that. They're normally fixed bias. Anything with an adjustable bias pot, I hope you're listening, is a fixed bias amplifier. Okay. Of course what that means is once you've adjusted it, it's fixed. It doesn't vary. Quite tricky, I think. Anyway, but there you go. So the other form of bias is cathode bias. And this is kind of variable bias. It's bias that adjusts on the fly, basically, whereas the other one was just literally fixed. This is a kind of like a thermostat in a house, a kind of self-regulating thing. So here's what we do here. Don't forget the grid still always has to be negative with respect to the cathode, but in this case we hold the grid kind of towards ground via some usually high value resistor. Don't forget the AC comes in here, so we're only talking about DC at the moment. So we hold the grid to ground. Well, if the grid's at ground, how can it be negative with respect to the cathode? Well, the answer is the cathode becomes more positive. So if this is at 0 volts and let's say this is at 35 volts positive, then I think you can see that the grid is negative with respect to this. It's in fact minus 35 volts with respect to that. So what they do is they forget this capacitor for the moment, they just put a resistor here, usually quite a high power resistor. The current comes down here. Any current flowing through a valve produces a voltage across. So this voltage rises here up until a level when the valve is biased correctly. So I think you can see it's probably self-regulating. If a lot of current flew through, if a lot of current came through here, this voltage would be high. It would go up and up and up and up and up, and the valve would turn more and more and more off because this would become more negative with respect to that. The more negative this is with respect to that, the less current flows through the valve. So if a lot of current were to flow through, this voltage would rise and this would become less negative with respect to, beg your pardon, this would become more negative with respect to that, hence turning off the valve. So the valve turns down, and if this current went too low, you'd have hardly any voltage across here, and so there would be hardly any negative drop across here. Let's say, being silly about it, this is 1 volt here, not much current flowing through here, just 1 volt there, say. Well, the grid's only 1 volt negative with respect to the cathode, and a lot of current would start to flow. So basically this kind of humps up and down within a few milliseconds and settles to a current. And if anything changes, if this resistor value changed a bit, it would all just automatically settle down to the new a sort of stable bias current. Right, so now remember we're forgetting this capacitor. So this settles down to, I don't know, 35 volts across this resistor. So the grid is minus 35 with respect to that. That's okay, it all ticks away nicely. However, AC wise, now we put an AC signal in, we get an AC signal across the load, but we're also going to get an AC signal across this resistor here, and that was the AC signal we were seeing when we hung our scope on there. Now we don't want that because that's just wasted AC across there. We don't really want any AC across there. We want it all to be across the load. So the way they do that is they put a cathode bypass capacitor, cathode resistor bypass capacitor there, usually some big electrolytic, 100 microfarads, 100 volts, whatever, and so that's a short circuit to AC. Don't forget the DC is completely unaffected, and so the AC sees no resistance here. In other words, it sees its cathode pretty much down at ground, and so the full voltage is developed across, AC voltage is developed across this load here. Hope you're following this. I barely am. So if this capacitor were to become open circuit, we'll get AC across this cathode resistor, which we don't want. We don't want any AC across here. And that's exactly what we saw. An effective AC across here is to reduce the output AC available here, and that's exactly what we saw on the output. If you remember, it was like 50% down on the bad channel compared to the good channel. So that's what tipped me off that it might be that capacitor, and all we did is put a new capacitor there and it all sprang to life. So I hope that was kind of educational for you. Well, there you go, another one under our belts, and I say get a lot of amps like this. This one's made in China, as indeed most of them are, and they all look the same, and they've usually got a similar kind of problem. We got a little bit unlucky with this. It wasn't just the valves, but I got a little bit lucky, well, experience I suppose, thinking it might be that cathode bypass capacitor, which indeed it was, and we got double lucky being able to fix that volume control, or greatly improve the volume control, without running up a huge bill for the customer to completely dismantle the amp to remove the volume pot. Don't get me started. Anyway, hope you enjoyed it, learned something, and I'll get you on the next video.